Okay, this question is on moments and it reads, Patrick and Patricia showed their class a magical balancing act. They both sat on one side of a uniform 6-meter plank. Patrick sat 1 meter from the pivot located 0.5 meters from the center of the plank. Patricia at 0.5 meters from the pivot on the same side as Patrick. The figure shows the magical balancing act. X represents the pivot point. Okay, so this is the representation. We have first we have Patrick, who is 1 meter from the pivot. We have Patricia, who is 0.5 meters from the pivot on the same side as Patrick. And also they said that the pivot is located 0.5 meters from the center of the plank. So this point is the center of the plank. The first question asks us to label as W the point on the plank where the weight acts. Because the plank is uniform, all the weight acts at the center. So we can safely write that the weight of the plank acts at the center. The next question asks for us to calculate the weight of the plank. Now, to calculate the weight of the plank, we need to remember two things. We need to remember how to calculate moments, which is the equation for moment is the force times the perpendicular distance. And also we need to remember the principle of moment that says the sum of the anti-clockwise moments is equal to the sum of the clockwise moments for equilibrium. So once the plank is balanced, it means it's in equilibrium, and the sum of the clockwise moments is equal to the sum of the anti-clockwise moments, and we can use that principle. So let's write that the sum of the anti-clockwise moments, AC WM, is equal to the sum of the clockwise moments. Okay, so it's the sum of the anti-clockwise moments is equal to the sum of the clockwise moments. Now we need to determine for each of these forces if they provide a clockwise or anti-clockwise moment. If we look at the 500 Newton force, if that was the only force acting on the plank, it will cause the plank to turn in this direction about the pivot point. It will turn in this direction. So we could say, or we see that the 500 Newton creates anti-clockwise moments. Same for the 400 Newton force. So we can write that the 500 Newton force creates a moment of 500 newtons times 1 meter. And the 400 Newton force creates a moment of 400 newtons times 0.5 meters. And that is equal to the clockwise moments. If we look at the weight and remove all the other forces, the weight will cause the plank to turn in this direction, and this direction is clockwise. So the weight creates a clockwise moment, weight times the distance from the pivot, which is 0.5. Okay, this is 500 Newton meters plus that's 200 Newton meters. That's equal to weight times 0.5 meters. Okay, let's put back in the meters up here. So that's 700 Newton meters equal to weight times 0.5 meters. Now we want to find what your weight is. So we're going to divide this side by 0.5 and divide this side by 0.5 as well. So we get 700 divided by 0.5, 700 Newton meters divided by 0.5 meters, which is 700 Newton meters divided by 0.5 meters is equal to the weight. When we divide that, we get 1400 meters, cancel meters, so we get 1400 newtons. That's the correct unit. Now the final question asks us